All right, we're going to talk now about momentum. So let's go back to this. We started the chapter with center of mass. So here's our center of mass equation, and this goes on for all the pieces of mass. And then we divide by the total mass, okay? For some system or some object. Well, if we multiply this up to here, I'm just going to rewrite this a little bit so that we get m times x center of mass, and let me just rewrite. So we rewrite it and we get this. So the reason I'm writing it like this is because I want to kind of take this and see if we can do anything with it. So for example, if we have, kind of going back to the beginning of this semester, we talked about the rate of change of position, which we call velocity. Well, if we were to kind of replace this with velocity, I mean, the same thing would hold true, that the total mass times the velocity of the center of mass would be equal to m1 times v1 plus m2 times v2, and so on. Alright, and so here we have, for a system of particles, the mass times velocity for each piece is going to add to be the total mass times velocity for each. Well, if we go ahead and find the rate of change of this, then we end up with mass times the acceleration of the center of mass. Okay, and before we continue writing out all those, where do we get this from? Where's that familiar from? Well, that's Newton's second law. The net force acting on a particle is equal to the mass times the acceleration. Okay, and in this case, a system of particles, and we've been all treating it so far. We've been just looking at the acceleration of the center of mass. Okay, well, if we look at this, this is useful. We talk about this for center of mass. Okay, we use this a whole bunch in the previous chapters, and this chapter we're going to focus on this piece here. We have this quantity, mass times velocity, that just turns out is going to be really useful for analyzing situations in which we have a system of particles or a system of objects interacting. Okay, so but before we continue, we're going to go ahead and define this quantity, and we're going to call it momentum, and we'll use the symbol P for it, and we're going to say momentum is equal to the mass of something times its velocity. Okay, so here we have, again, momentum, P, is equal to mass times velocity. We're also going to connect this back to Newton's second law again another way. So we know that F is equal to the mass, and remember, F being the net force is equal to the mass of an object times its acceleration. Well, if A is just equal to dv, and we'll use average velocity here, so let's say the change in velocity divided by time. Okay, we're going to take this and put it right here for A. Then we get that F is equal to m times delta V over T. And what we can do is we can actually take this delta and put it out front here. Okay, which tells us that the net force on objects is equal to delta mv over T, or we've just defined this quantity mv as momentum, so we can rewrite this and say that force is equal to the change in momentum with respect to time. Okay, and so basically the force on something is equal to the rate of change of its momentum. Okay, and this concept we're going to come back to a couple times this chapter. We're going to step away from it and just focus on momentum right now, but we're going to come back to this. This is a pretty important concept for us. Okay, so we'll keep coming back to this. Okay, so if momentum is equal to mass times velocity, then we can find the momentum of an object just by multiplying its mass times its velocity. Okay, so let's say we have a 5 kilogram mass, and let's say it's moving at a speed or velocity of 3 meters per second. What would be its momentum? And let's do another one for another object. Let's say we have a separate object that has a mass of 1 kilogram, and let's say it's moving with a velocity of negative 3 meters per second. Let's find its momentum too. Okay, so for the first one, m times v, 5 times 3 gives us 15 kilogram meters per second. And then for the second one, 1 times negative 3 is going to give us negative 3 kilogram meters per second. Okay, so we've calculated momentum. One other thing we're going to try, we're going to look at the momentum of a system of objects. Here we have a system of 3 objects, one that has a mass of 1 kilogram and a velocity of negative 3 meters per second. This one has a mass of 3 kilograms with a velocity of 2 meters per second, and this is a mass of 1 kilogram with a velocity of 1 meter per second. So we're going to say that these 3 objects make up our system. And so our goal here is to find the total momentum of our system. Well, the way that we do that is by adding the momentum, remember m times v, for each piece in our system. So we're going to add up the momentum for all 3 and see what we get. The momentum for the first piece, this one right here, for the second one here, 3 times 2, and this last one, 1 times 1, we get negative 3 plus 6 plus 1 for a total momentum of 4 kilogram meters per second. Now, if you remember back to our first slide where we said that, where we kind of showed the examples, where we kind of defined momentum, we can, if we have the total momentum of a system, if we divide it by the total mass, okay, we get the velocity of the center of mass, okay? And so this system here has some center of mass, and we don't know its location because we don't know how far apart they are, but we can actually find how fast the center of mass is moving based on how fast each of these is moving. And it doesn't take that much more because it's just our total momentum divided by our total mass. So the next step would be to take our total momentum here and find our total mass. So go ahead and do that now. So we take our total momentum and divide by our total mass to get the velocity for our center of mass. Okay, and so that's going to be 4 divided by 3 plus 1 plus 1, or 5 kilograms, okay? And these are kilogram meters per second on top. And so if we divide by all that, for velocity, we get the velocity of the center of mass is about 0.8 meters per second. Okay, so that concludes our video on momentum. Before we stop, I just want to point out that this concept of momentum itself is just a very abstract thing that ends up being very useful when we talk about systems of particles. Okay, the unit kilogram meters per second doesn't really mean anything, but it's useful in the way that momentum connects to a lot of the concepts that we already know.